Hello everyone! Ever wondered how to supercharge your big data processing in PySpark? Discover the secret weapon that can speed up your tasks exponentially. Let's dive into the power of caching. Cache is a method used to persistently store a data frame or RDD in RAM memory across operations to enhance performance by avoiding recomputation, typically employed when you need to repeatedly access the same dataset. When to use cache in PySpark. Iterative algorithms. When running iterative algorithms such as machine learning training processes, where the same dataset is repeatedly processed in multiple iterations. For example, in machine learning, training a model often involves multiple iterations over the same dataset to optimize the model parameters. Without caching, the data would be read and processed from the source in each iteration, leading to significant overhead. By caching the dataset, you ensure that it is loaded into memory once and reused across all iterations, drastically improving the performance and efficiency of the training process. Repeated data exploration and querying. During interactive data analysis and exploration, where the same dataset is queried multiple times with different filters, aggregations, or transformations to gain insights. For example, in exploratory data analysis (EDA), data scientists often perform multiple queries and transformations on the same dataset to understand its structure, identify patterns, and extract insights. By caching the dataset, subsequent queries can be executed much faster because the data is kept in memory, reducing the need for repeated disk I/O and computation. When not to use cache in PySpark. Large datasets exceeding available memory. When working with extremely large datasets that cannot fit into the available memory. For example, caching large datasets in memory can lead to out-of-memory errors or excessive garbage collection, which can degrade performance and potentially cause the Spark application to crash. If the dataset size exceeds the available memory, Spark will struggle to keep the data in memory, leading to inefficiencies. One-time computation. When the data is used only once or the computation on the dataset is not repeated. For example, if a dataset is processed through a series of transformations and actions only once, caching it will not provide any performance benefit. Caching introduces overhead by storing the data in memory, which is unnecessary if the dataset is not reused. Here are the advantages of caching in PySpark. Improved performance. Caching allows frequently accessed data to be stored in memory, reducing the need for expensive recomputation. This significantly improves the performance of subsequent operations, as the data can be quickly accessed from memory rather than being recalculated. Reduced overhead. By caching intermediate results, PySpark avoids the overhead of recomputing the same data multiple times. This leads to faster execution of complex data processing workflows, especially when dealing with iterative algorithms or interactive data analysis. Here are the disadvantages of caching in PySpark. Increased memory usage. Caching stores data in memory, which can lead to increased memory usage, especially for large datasets. If the cached data exceeds available memory, it may result in memory pressure and potential out-of-memory errors. Risk of stale data. Cached data may become stale if the underlying dataset changes between caching and subsequent access. This can lead to incorrect results or unexpected behavior if the cached data is not invalidated or refreshed appropriately. Let's understand the performance impact of caching with an example. In this example, we have 4 transformations applied to the data frame df. Without caching, each action would trigger the entire data frame lineage to be recomputed from scratch, leading to redundant computation. However, by caching df5, subsequent actions can reuse the cached data, resulting in significant performance improvement, especially in scenarios where the same data frame is accessed multiple times. I trust you found this video helpful. Thank you.